So why is it that if you substitute an x plus 3 in place of an x, that's going to shift the function to the left? Because it seems like logic, if you put a plus 3 on something, doesn't that go to the right? So for example, if you're talking about the number line, here's a 7, and then you add 3 to that, that moves you over to the right, and you get to 10. So shouldn't you be moved to the right? Well, it turns out you actually get moved to the left, and we're going to find out why. Okay, so what I can do is I can take an example function and say, what if the function was x squared? And then compare that one with the function, and I should use a different letter because I just used f for that one. I'll use g. So what if you replace x with x plus 3? Does that actually shift it to the left? Let's see. So go to the graphing calculator, go to y equals, and first graph x squared. That is a parabola. Let me just center it a little bit. All right, there's the parabola. Then go to y equals, leave that one there, and then make this one parentheses x plus 3 being squared. And this one is going to be sort of a bluish purple color. And then look at the graph, and the blue one is actually shifted to the left, and in fact it's shifted to the left by 3. So why is that? So basically when I had the first function, so I had y equals x squared, or f of x equals x squared. And now to move this function, basically you could just get its vertex, which is that bottom point right there. And if you move the vertex to the right or to the left, then that's going to move the whole graph. So how do you move the vertex to the left or to the right? Well, notice that for that point right there, that y is equal to 0. And then we could find out what x equals. So just substitute y equals 0. And you could take the square root of both sides. The square root of 0 is 0, so that means x equals 0. Okay, good. That's the origin. Then what about when you have y equals and you replace the x with x plus 3? Well, that does make a parabola. In fact, it makes a parabola over here, but suppose we didn't know that. Suppose that we don't know where it's crossing the x-axis. Is it crossing over here? Is it crossing over here? Is it actually staying here? That's a question. So is it moving to the left or to the right, or is it staying the same? Well, no matter what, all three of those question marks, they all have y equals 0. So that means we could do the same type of work and say, well, what if y equals 0? And then solve for x to find out which way did x go. Like with the last one, you can take the square root on both sides. And on the left, the square root of 0 is 0. On the right, it gets rid of the square. And finally, here's the reason it actually moves to the left. Because now, to solve for x, I need to do the opposite of plus 3, which means I have to do minus 3. And that is where it says x equals a negative 3, which means these two question marks were wrong. It actually gets moved to the left. Now let me just clean up my work a little bit. Okay, that was a little bit too much. It's okay, I've still got a pen. So x equals negative 3 is over here, and then you make the parabola. And that will work with every function. So it was actually this step right here that's the reason. This is why it gets moved or shifted to the left. And then as just an add-on, if it said y equals x minus 5 squared, and you did the same thing and set it equal to 0, then even though it says minus, that actually shifts it to the right. So with a minus in the parentheses, that actually shifts it to the right. And with a plus in parentheses, it shifts it to the left.